Hi, welcome to the 10th lesson on electricity. In this lesson, we're going to learn about components and resistance. And we're going to answer a question I'm sure you've had whilst using your phone. And that question is, why is my phone overheating? There are lots and lots of videos about this very question. Let's have a go at answering it using what we've learned so far. But first, let's have a quick recap. What is resistance? Resistance opposes the flow of current. And it's a vital concept in understanding why our phones heat up and how electrical energy is converted to thermal energy or light energy, like in the case of this filament bulb here. In this model, we can see the electrons flowing through the lattice. But actually, these electrons are constantly banging into and colliding with these positive ions. This creates a lot of resistance. But this is how energy is transferred. The electrical energy in the electrons is converted to thermal energy or light energy as the collisions happen. So it's those collisions that allow energy to be transferred. These collisions cause the ions to vibrate and heat up, and this is called the heating effect. This thermal energy is often considered wasted energy, but it's extremely important in understanding electrical components. In some cases, if a wire gets too hot and the heating effect is very significant, the wire can melt. So in a lot of cases, it's beneficial to use low resistance wires and reduce that wasted heat energy. However, in some cases, the heating effect can be useful. Examples of this are toasters and electric heaters. These appliances rely on the heating effect for their function. As a result, they have high resistance wires. This causes an increase in collisions between ions and electrons. As a result, that increases the heating effect, and therefore it increases the thermal energy generated. This is the heating effect we learnt about earlier. So when you have very well toasted bread, you often have a high number of collisions between the ions and electrons. And if you want to have lightly toasted bread, you'll have a relatively low resistance. Now, how can that actually be controlled? Let's take a look at electrical components individually. We're going to learn about four main components. The first is a diode, and it has this symbol. A diode is a component that lets current flow in only one direction. As we learnt about with AC and DC, alternating current and direct current, current can flow in two directions. And a diode will correct that and only let it flow in one. It's often used in chargers and LED bulbs. The next is called a light-dependent resistor, or an LDR. And this is a resistor whose resistance reduces when light shines on it. And as a result, it's often used in automatic streetlights. Next, we have a thermistor, a resistor whose resistance reduces as it's heated. And this type of resistor is often used in fire alarms. Next, we have a filament bulb or a lamp. This bulb contains a thin coil of wire which is heated when current passes through it. As that happens, light is produced. And this is often used in light bulbs, however not so much anymore because they're so inefficient. And next is a resistor and variable resistor with the following symbols. And these components reduce the flow of current. A variable resistor has a variable resistance, and you can choose the resistance depending on the application. This is often seen in brightness and volume controls on our phones. each of these components has a different relationship between voltage and current, and we're going to look at these in the form of a graph. Based on the graph, I want you to think about what component this is, what's the trend in the graph, to explain the trend in the graph, and finally, does this component obey Ohm's law? If you've forgotten what Ohm's law is, that's okay. Ohm's law states that in a component, the voltage is directly proportional to the current flowing through it, provided that all physical conditions like temperature and light remain constant. Let's take a look at the first graph. What type of component do you think this is? Pause the video and examine the graph. This graph is actually for a diode. And we can see that current and voltage are not proportional. And the reason behind this simply goes back to the function of a diode. The diode is a component that lets current only flow in one direction. As a result, at very low voltages, like 1, 2, and 3 volts, a lot of current can pass through. On the flip side, when you reverse the voltage to the negative direction, no current flows through at all. As a result, you can firmly say that this component does not obey Ohm's law. Let's take a look at another one. Pause the video and see if you can figure it out. This component is a filament lamp, and we can see that current and voltage are directly proportional, but only at very low voltages. Remember, voltage is the energy per charge, so this relationship is only proportional at low energy. As energy increases, or voltage increases, in the positive and negative direction, this relationship no longer holds true. This is because as voltage increases, the collisions in the filament also increase, which increases resistance and therefore reduces the flow of current at such higher voltages. We can also say that this component does not obey Ohm's law. Next, we have another graph. Pause the video and see if you can figure it out. This component is a resistor, and we can see that current and voltage are directly proportional. As voltage increases, so does current, and as voltage decreases, current decreases as well. And this resistor does obey Ohm's law. One more final graph. Pause the video and see if you can figure it out. Make sure to take note of the axes and the labels. You should have been able to identify that this graph could represent a light-dependent resistor or a thermistor. We can see that as temperature and light intensity increase, resistance decreases. This is characteristic of an LDR or a thermistor, and we can say that this doesn't obey Ohm's law because the physical parameters of temperature and light are not held constant. That's the end of this lesson. I hope it's been useful. If you have any questions, please do ask.